Okay, here we go. Number 5. This one's a little bit tricky. The only tricky really part about this one is that we're only given one reactant, right? So people get a little bit confused here, but don't get confused. If you're just given one reactant or one product, it's just that is what's getting oxidized and reduced. That's what's involved in both the oxidation and the reduction. So, for example, for this one, arsenic goes from a 0 to, in this case, we have -8, +2, it's a +5. So it goes from a 0 to +5. That's the oxidation. In this case, hydrogen is a +3, or really each one's a +1, and you have 3 of them, and then so therefore this one's a -3. Okay. If you didn't know this too, I'll show you when we get to the other part how we know this is a -3. How do we know? Right. I'll show you a little bit later how we figure that one out. Okay. So let's write the balanced half reactions here, or actually write the half reactions, then balance them. So this one first, and then the other one second. Just so you know, this is the oxidation. One in red is the oxidation. I know it's kind of opposite of what I've been doing, but it doesn't matter what color I use. Okay. Oxidation and reduction. Okay. Next, balance everything that's not hydrogen and oxygen. Done. Balance oxygen by adding water. We have 4 oxygens there, so 4H2O. Next, balance hydrogens by adding H+. Careful though, I made a mistake. I did this one before and I forgot about these 2 hydrogens here. So yeah, there's 8 hydrogens here. However, there's 2 here, so we only need actually 6. Okay. The bottom one, or the reduction, we need 3. Okay. Next, balance charges by adding electrons. On this side, the charge is 0. This side, the charge is +5. So we have to add 5 electrons. Okay. The bottom one, we have 3 plus and a 0. So therefore, we need to add 3 electrons. Now it's kind of ugly there. Well, let me just make it better looking. So what I said before is, how do I know that this arsenic is now a negative charge? Well, and it's the reduction. Because when I do the balancing, I see that I have to add 3 electrons here. So we're adding 3 electrons. That means we're getting a reduction occurring here. And now that the AS is going to be the arsenic is going to have those 3 electrons on it. Okay, because H is positive. Arsenic's got to take those electrons on. Okay. Next step, we got to multiply so that the electrons are even, right? So this one we got to multiply by 5. This one we got to multiply by 3. Okay, rewrite them. So 12 H2O plus 3 arsenics yields 3 H2ASO4 plus 18 H pluses plus 15 E minus. The bottom one. Now we have 15 E minus plus 15 H plus 5 arsenics yields 5 arsenic H3. Okay. Just gonna erase these. Typically, again, when I would rewrite these, I'd actually write them down further on my paper because I'm going to combine them. So I'd write them down further, and yeah, I could even put them together to begin with if I really wanted to. But okay, next step, cancel everything. 15 electrons here, 15 electrons here, cancel. Okay, 15H plus 18H plus, there's 3 left over. Okay. We can combine this and this. Combine them, not cancel them because we're on the same side. Okay. So let's rewrite the whole entire equation. 12H2O plus 8 arsenics yields 3H2ASO4 plus 3 H pluses plus 5 ASH3. Okay, so now we just want to make sure that the charges on both sides are balanced. And don't forget that this actually has a -1 charge. I missed the negative charge here. That's very, very important because this and this charge, so negative, have to cancel to get 0. So 0, 0. We have 8 arsenics on this side, 8 on this side. 24 H's, 6 plus 3 is 9, plus 15 is 24. 3 times 4 on this side is 8, plus, sorry, 3 times 4 is not 8, it's 12. Oh my goodness. 12 times 1 is 0. So there we go. That's the balance reaction. It's always really important that you check it. Checked. Okay, and that's it. Donezo with that one.